and welcome again to my Physics Online video lecture series. Today's video, we're going to be talking about the quadratic formula. Now this is another video in my series of mathematics review videos that you should be watching to review the basic math concepts that underlie any calculus or even algebra-based physics course. So these are again, reviewing mathematics that you should already know if you're trying to take a physics course, and that will help you as you go along the course.
Now, as I've said, today's video is about the quadratic formula, and we begin by asking sort of where does it come from. So let's say that you have a quadratic of some sort. So you have some sort of quadratic equation. So a quadratic equation is an equation that has the form of something like a times x squared plus b times x plus c equals 0. Alternatively, it could be a times x squared plus b times x equals c. Now note that this c and this c can't be the same, since I would have had to subtract it. So if we want it to be the same for consistency, we'd maybe say equals minus c. But note that a, b, and c are all just numbers. They could be positive or negative. Okay. So how do you go about solving this equation? So one way of doing it is what's called completing the square. So let's say that I have an equation of the form maybe like x squared plus, let's say, 6x is equal to, say, 5 or something like that, or 15. Basically, whatever number you want here. I'll make it 16 just for the fun of it. So how do you complete this square? Well, this x squared is really like a 1x squared. This number right here is 2 times 3. And so I would notice that if I have x squared, x plus 3 quantity squared, that would give me x squared plus 6x plus 9. Okay, but I'm missing 9 from this side in order to be able to make this squared quantity. So what I have to do is add 9 to both sides. Let's do that in a different color just to be clear that we're adding 9 to both sides in order to complete the square. So there's a plus 9 here, and therefore I have to add a plus 9 over to this side. Okay, well, that means I now have x plus 3 squared is equal to 25. Okay, and now my next step is I take the square root of both sides of the equation. And so that gives me x plus 3 is equal to, and then this side over here, the root 25, becomes either positive or negative 5. Okay, so that means that x can either be plus 5 minus 3, or x can be minus 5 minus 3. Basically, I'm subtracting 3 from both sides. And so this basically means x is equal to either positive 2 or negative 8. Those are the possible solutions to x for this simple example that we've come up with. So this quadratic formula basically it comes from essentially completing the square with this arbitrary equation form, okay? And then this whole process of solving. Now, I'm not going to do all of that here because you should have already seen this in a math course prior to coming here, assuming, of course, that you're coming here because you're taking a physics course. So you should have already taken the math course in which this quadratic formula is derived for you. But the end result is if I have a quadratic equation, so if a times x squared, let's make it a capital A just for variety's sake, if a times x squared plus capital B times x plus capital C is equal to 0, it follows that the solutions for x must be, oops, having a little trouble writing this morning. X must be equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a, where a, b, and c are sort of arbitrary constants or arbitrary numbers. So a, b, c all have numerical value, presumably given in the problem that you're trying to solve. Could be positive or negative, and they don't need to be integers. So any number. They can even actually be, your solution for x can be complex, but in physics, x will typically be real. So it will have some real value. This is kind of an aside, but a fun aside nevertheless. In quantum mechanics, x might stand for some observable. Not that we necessarily are using the quadratic formula to solve for it, but in quantum mechanics, x might stand in for some observable. And if that is true, then the measured possible values of x must all be real valued. And that tends to hold true for a lot, not all, but a lot of physics. If it's an observable quantity, then it will typically have real values. Now, there are some cases where you will get imaginary values in some sense as a place-keeping measure, but that's neither here nor there. This is your quadratic formula. If you don't already know it, then you should write this down and I guess commit it to memory so that you're not having to look at a note card when you're taking a test. And I suppose I owe some example using the quadratic formula. So in this example, you're solving for y given a quadratic formula. Except for that I left off the square for the y here. Should be 2y squared minus 5y. If it's just 2y minus 5y plus 12, then it's a pretty straightforward linear equation. You combine like terms, get negative 3y equals negative 12, and therefore y is 4. But as a quadratic formula, or as a quadratic equation, you're going to have to either complete the square or use the quadratic formula. And so a quadratic formula says that this number right here is akin to A, this number right here is akin to B, and this number right here is akin to C. So what we expect our answer to look like is y is equal to negative of -5 plus or minus square root of -5 squared minus 4 times 2 times 12, all divided by 2 times 2. Okay, so this is negative b plus or minus b squared minus 4ac over 2a. And so from here, you may, use calculators or something. You've got y is equal to 5 plus or minus the square root of 25 minus, and this is 4 times 2 gives me 8 times 12 gives me 96. So minus 96 divided by 4. Okay, so in this case, y is not going to have a real value. Probably means that this problem is not being solved for physical quantities, or you would have a sign error somewhere in your quantities. But given the equation we have, this is what you end up kind of getting. So 5 plus or minus the square root of negative 71 divided by 4. From a strictly, like if you were doing this on pen and paper and you handed this in as the answer in the class that I'm teaching kind of thing, this would actually be acceptable. But if we are trying to hand it in for like a homework system or a test that's taken online, quiz that's taken online, where there has to be just one numerical answer, you'd want to go ahead and put it into the calculator. So what is the square root of 71? Well, since it's negative, what we end up with is y is equal to 5 plus or minus 8, roughly 0.4, 8.426. So let's call this 8.4 times the imaginary number divided by 4. Okay, so you could do that. You could kind of divide both sides or both numbers by 4. So this would be 1.25. This is 8.43. If I divide by 4, I end up with plus or minus 2.10i. That's your solution. Okay, let's do another one. We want to solve for z given 3z squared minus 4z minus 12 is 13. So the first thing we have to do is get it into the form of that quadratic formula. If we're going to use the quadratic formula, or get it into the form of the basic quadratic equation. So this is 3z squared minus 4z minus 25 equals 0. So I'm basically just subtracting 13 from both sides of the equation. Now again, this term right here would be a, this term would be b, and this term would be c. So again, I can set up my quadratic formula. I therefore get an equation that looks like this, with all of our b's, a's, and c's plugged in. So z would look like 4 plus or minus the square root of 16, and I have a minus. 4 times 3 is 12 times negative 25. So that becomes 16 plus whatever 12 times 25 is. I believe that comes to 300 divided by 6. Okay. So that is 4 plus or minus the square root of 316. Square root of 316 is about 17.8 divided by 6. So that gives us values of positive 3.63 and negative 2.30. And that's it. Thanks for watching.